Good morning, students. So in this present class we are going to study regarding how to solve problems using slope deflection equation. So here we are going to discuss in detail regarding steps involved in slope deflection method. So basically in this method the ultimate aim of the problems are determining final moments, determining moments generated in each members of the given structure. So what are the basic steps involved? Let us consider the steps involved in slope deflection method. The very first step is kinematic indeterminacy. So in previous course, statically determinate structures, we all studied what is meant by statically determinacy, what is meant by kinematic indeterminacy and all. Here the mainly these methods of your whatever analysis of indeterminate structures mainly depending on kinematic indeterminacy. So basically we are going to determine what is the kinematic indeterminacy of the given structure. Let us say for an example, here I have considered two continuous beams. Let us say in first continuous beam I am having two span. There are two span AB and BC. How to compute kinematic indeterminacy? Let us consider each supports. When you are computing kinematic indeterminacy, consider supports. Consider joint supports. At joint A, we are having fixed support. We know that what is the feature of fixity? Fixed support is a rigid support. It is not allow horizontal movement. It will not allow vertical movement. It will not allow rotation. We know that. So the possible displacements at any joint, there are three possible displacements. One is horizontal moment, vertical moment. Both horizontal as well as vertical moments are called as translations. Fixed support will not allow translation and rotations. Hence, zero translation horizontal, zero translation vertical and zero rotations at fixed support. At joint A we are having fixed support. So the joint displacements are 0. Next, if you come to joint B, we are having simple support. At joint B we are having simple support. See, if you consider joint B, the possible displacements are two translations and one rotation. That's the possible displacements. But because of this reaction, because of vertical prop, the vertical displacement is not allowed. That reaction will resist the displacement in vertical direction. Because of this fixity, and also our assumption in solving indeterminate structures, axially rigid structures. Axially rigid means there is no axial displacements. So what are axial displacement? X-axis, Y-axis. So in x-axis, because of this fixity, or if I am going to assume axially rigid, this is 0. The horizontal displacement is not allowed. The only possible is rotation. Rotation is possible. Here there is no reaction to resist the rotation. Hence theta B. Similarly, joint C, horizontal displacement not possible because of assumption axially rigid, or here you are having fixity. Hence, because of this fixity, this beam will not move in horizontal direction because of this reaction, because roller axially stiff, one reaction. Because of this one reaction, it is 0. So what is the total kinematic indeterminacy of given beam A, B, C? There are two kinematic indeterminacies. Those are theta B and theta C. Theta B and theta C. Similarly, if you consider second example, here simple support, here you can say that sir, horizontal displacement is possible, but our assumption is axially rigid. When you are going to assume axially rigid, axial displacements are ignored. Hence, this is also 0, 0, 0. Because of this vertical props, vertical reactions, 0, 0, 0. There is a rotations in all three joints, theta A, theta B, theta C. Therefore, what is the kinematic indeterminacy? 3. Theta A, theta B, theta C. Theta B and theta C. So this is the very first step, identifying of kinematic indeterminacy. Please keep in your mind, here we are assuming axially rigid. Axially rigid means there is no translations. The possible displacements are only rotations. Those rotations we are going to determine as an unknowns. Once we determine those kinematic indeterminants, we substitute that kinematic indeterminants into slope deflection equation. We are getting the final moments. That is the way how to solve problems using slope deflection method. The very first step is determination of kinematic indeterminates. Step 2, fixed end moments. Step 2, fixed end moments. Why we have to determine fixed end moments? Because if you observe the slope deflection equation, the slope deflection equation is MAB equals MFAB plus 2EI by L into 2 theta A plus theta B plus or minus 3 delta by L. Similarly, MBA equals MFBA plus 2EI by L into 2 theta B. See, BA 2 theta B, AB 2 theta A plus theta A plus or minus 3 delta by L. Here we are having fixed end moments. Therefore, we are going to compute fixed end moments. We are having standard set of equations. If the span is carrying entire UDL, then AB equal minus WL square by 12, BA equals plus WL square by 12. Why this is minus? If you consider this moment, here it will rotate in clockwise direction, the resisting moment is anti-clockwise direction, that's why it is minus. If you consider, take moment here, it will rotate in anti-clockwise, the resisting moment is clockwise, hence it is plus. So these are some standard cases. The span having full UDL, the span having central point load, the span having eccentric load AB distance, the span having couple, clockwise couple, anti-clockwise couple. For span having point load at center, minus WL by 8 plus WL by 8. The span having eccentric distance, minus WAB square by L square plus WA, not A here, have to replace that, PA square by L square, BA square by L square. Similarly, next, if you are having couple exactly at center, see the couple is uniform throughout. If you are having clockwise couple, plus M by 4. Don't take it as a resisting. No. Couple is same throughout the body. It's not a force. If you are having, these are forces. UDL, point load are forces. If you are having forces, you have to take moment. Couple means it's already a moment. Why you have to take moment? Whatever the existing moment, the same clockwise effect is here. Clockwise effect is positive, here plus M by 4. Anti-clockwise effect is negative, minus M by 4. These are some important formula you have to remember to solve the problem. The standard cases you may expect in examination is the continuous beam is subjected to UDL, point load or couple. Hence I have given 3 fixed end moments, 3 set of fixed end moments. Please remember these things when you are, it is very essential when you are solving problems. This is already I have discussed slope deflection equations, a standard equation you have to remember, where delta is the sinking with respect to support in case of beams. You have to carefully observe the problem. In problem, if it gives like the support A sinks by 2 mm or rises by 3 mm or anything, you have to carefully observe and apply the concepts. I will discuss in detail regarding sinking of supports in next class. So here, once you determine fixed end moments, substituting this equation, you are getting equation in terms of unknown as theta A, theta B, What is theta A, theta B? Those are all kinematic indeterminates. So you are getting some set of equations. Each span having two equations. Each span having two equations. AB for AB, AB BA. For BC, BC CB. For CD, CD DC. Like that, each span having two equations. So construct slope deflection equations depending on given continuous beams and loadings. The next step is joint equilibrium condition. What is meant by joint equilibrium condition? See, this is once again this is related to your equations of equilibrium, that is indeterminacy. So if you are having fixity, there is no displacement, right? So for an example, if you consider this continuous beam, joint A fixed, so there is no displacement. So this is not required to consider as a joint equilibrium because it's already in equilibrium. But joint B is an intermediate support, it's not in equilibrium. We have to bring the joint in equilibrium. What we have to do? We have to take summation of moments. What is meant by summation of moments? We have to take BA, we have to take BC, MBA plus MBC, MBA plus MBC. Here it's already in equilibrium. It's in equilibrium because of fixity. If you consider this span, you have to take this moment. That is CB. That is CB. MCB equals 0. This structure is having two joint equilibrium. One is intermediate joint, one is end joint. You are not considering joint A because joint A is fixed. It's already in equilibrium. Similarly, if I am considering another example, here I am not having any fixity at end supports. Then what is the joint equilibrium condition? Joint A, MAB equals 0. Joint B, BA plus BC equals 0. Joint C, CB equals 0. These are the things we have to understand when you are solving slope deflection equations. It's very, very important. We have to bring that particular structure to equilibrium. So when we are substituting MAB equals 0, we know that we are having some certain slope deflection unknown equation in forms of kinematic indeterminates in previous step. So now we are substituting here. We are getting simultaneous equation. Equation 1, equation 2, equation 3. In next step, determination of kinematic indeterminates. We are having simultaneous equation. Solve equation 1 and 2, 3. 1 and 2, 2 and 3. So you are getting unknowns. Unknowns here, theta A, theta B, theta C. Unknowns here, theta B, theta C. We are getting theta B, theta C, or theta A, theta B, theta C in this step by solving joint equilibrium conditions. Once we got kinematic indeterminates, the last step is final moments. How to arrive final moments? We are having certain set of equations in step 3, that is slope deflection equation. So MAB equal MFAB, theta A, theta B, and so on. So we known values are theta A and theta B. In this step we are known. So we just substitute those values in slope deflection equations. We are getting for each span two final moments. So we are getting MAB value, MBA value, MBC value, MCB value, all those things. So these are the basic steps you have to remember while you are solving problems. The last step is computation of shear force diagram and bending moment diagram. We are discussing in detail when you are considering the problem. Okay, so as of now you have to be practiced with what is meant by kinematic indeterminates, what is meant by fixed end moments, how the slope deflection equations can be formed, how to apply joint equilibrium conditions, and how to solve those joint equilibrium conditions using simultaneous equations, and finally how to compute final moments. So we are having basically 5 to 6 steps. That is, the very first step is determination of kinematic indeterminates. Second step is fixed end moments. Third step is slope deflection equation. Fourth step is joint equilibrium condition. Fifth step is for using the simultaneous equations of joint equilibrium condition, we have to determine unknown kinematic indeterminants. The last step is final moments. Just substitute those unknown whatever we computed kinematic indeterminants into slope deflection equation. These are the steps you have to remember to solve this problem. So in next class we are going to discuss in detail regarding sinking of supports and how to solve beam problem, frame problem, sway and non-sway, all the things in coming videos. Thank you all.